using agents or coding for quite some time, and I want to talk about it. So, last 6 months, there has been an explosion of AI tools. Like LLMs has been there for like many years now. Like ChatGPT was released in 22, and like we've been hearing a lot about coding agents. So, like first thing is like what is a coding agent? So, coding agent is something that we can use in collaborative manner to code. Like since like from planning to feedback analysis or to write code. Like it can read your code, understand the context out of it, and like to the given task, we can write code about. So basically, like what you see, you give a task, what agent goes, it reads your existing code base, it does analysis, it like creates a solution. Solution that you create, it can be like you can iterate with the coding agent to get feedback on it, or to write code afterwards. So, like, how does it work as a normal coding cycle that we do? Like, in the example you see, it just added a change and ran some test. So, in a similar manner, how we programmers code, where we like want to do something, we create a solution about it, write some change, and run tests about it. So, it works in a similar manner. So, I use coding agent for a whole host of things. Like, so since the Cloud Code came in, like it became my default terminal, and like when it comes to reading documentation or like debugging issues, write code, like PR reviews, CI pipeline debugging, like everything goes through the coding agent. Like the current landscape, like we have new things coming every week. We have like a lot of foundation model almost coming in every month. Coding tools being launched every month, and like a lot of these integration coming in a lot. So, if you have any questions, just feel free to interrupt me. So, like as I said in the beginning, why now all of a sudden like LLMs have been there for like quite some time, but why just now? So, if you've noticed recently in few months when Sonnet 4 or Opus 4 launched, it changed quite dramatically. Reason being, like coding is more about analysis and like going through the loop. Like we just don't decide on a task, create a solution in our head, and just write code about it. It's an iterative process where we do something, try something out, and make those iterations until we get like a satisfactory result. Similarly, work with these new models where they are able to follow the instructions very well, call these tools to do analysis, write code. So since then, and alongside that, like Cloud Code was launched. Cloud Code was the first coding agent with agentic loop in it, with these new models who are good at the rule following part of it. So when Cloud Code came with the Sonnet 4, we were able to like do the proper analysis of code, iterate over the plan, write code. Another thing is like there has been a concern of token cost. Like most of the models have this per million token pricing. And recently, like a lot of these agents started launching monthly pricing. So with the monthly pricing, we have a cap, and like we pay that pricing, we don't have to fear about okay, if I use it too much, like I have to pay a lot more. Like we just pay once a month, and we can use throughout the month whatever, how much ever we want. Like all of them have generous limits with monthly plans. So this all has contributed a lot to people using these agents a lot. So just a question now, how many of you use like coding agents like on a daily work life? Okay, quite a few. Cool. So why like so we talked about like there are so many agents launching every week. So like what's happening? So like okay, why is it very easy to build those agents? Recently there has been a blog post from AMP on like how to build an agent. So like the core part of agent is like very simple. So we'll talk about it. Like this just tells you like okay, how can you build an agent with 400 lines of code. There have been a lot of tools in the market, like say last 2 years, the IDE extension like GitHub Copilot, Cursor, or now the terminal based AI agents we have like Codex or Cloud Code, IDA, a bunch of these other agents. And now we have these specific agents like for specific tasks like code reviews we have like Code Rabbit, and we have these vibe coding tools where we can like build front ends. Like for example, we have seen like Bolt, Lovable, V0 from Vercel, things like those tools. So I'm not here to talk about any specific agent or a tool. Talk about like how do you like write production code, or like how do you actually use agents in the production environment. So, like to understand it, like we need to understand how the agents work entirely. Like what is the secret sauce of it? Like initially, I just told like okay, everyone is building agents, and like with 48 lines of code itself, we can write an agent. So how does this work? Like the core part of an agent work? We have an LLM model, which is where all the magic lies, where we can like get the intelligence part of it, and we have an environment. Environment is like code base. All the terminal, all the tools we have on a computer, that is an environment. So what an agent does, it can literally like interact with the environment, get some feedback and run into a loop until we get to do a task. For example, let's say you need to make a small change. Let's say we need to change the text of a button in our web application. So you just instruct your agent to change that button in the web application. What it needs to do the first thing? It needs to find that particular button in the code base. So, like what it needs to do in terms of those tools, it needs to find those files where the exact button code lies. So, what we do, first of all, it needs to find that particular file itself. So, in the file system, agent need to use some particular tool to read files. Like we use list files, libgrep, bunch of the other tools. And in the particular file, now we need to find the block of the code where the exact button lies. So we need to find the particular button itself. For that, like we need to use another tool. And then like once we find the button, okay, we need to change the text to let's say apply now. So it will then apply that particular change. It will compile and it will run the test. So basically, these are the different types of tools like reading files or like making a change, replace string. And particularly broader like bash as the entire tool that is given to an agent, so that like wherever it needs to do an action in the particular environment, like is our code base, it can do that change. And also let's say when we need to do a more complex thing that requires let's say searching of the web or reading documentation, it can a lot of these agents provide web search tool where we can like search on the web for the documentation or specific thing. Instead of we going on Google and like doing that search, it can do on its own. So why like then if this is the case, then why we have so many different agents and like why every company is building those agents? So one of the thing with the models is there is a like binding between the model and the agent, model and the tools. So those tools that we talked about, those like to use those tools, model need to be trained on that. Model need to know that okay, I need to use those tools. Even though explicitly we can tell the model that okay, use these tools. Like models are not very good at rule following in some case, but what happened recently with the Sonnet 4 and Opus 4, the recent models, they were trained specifically for the tool uses. So these tools that I talked about, like for example these bunch of these tools like whether writing shell script or like reading a file or using libgrep, those are the specific things that model has been trained on using it. So that creates like a different thing. Like instead of earlier models where we have like let's say O3, O4 models, from OpenAI, where those were trained on the generic data or the generic code, these new models that have been trained on specific tool, like so how to use the specific tools for the coding purposes. So that's the reason the models become very good at using those tools, because they've been trained on those. So again, the tool matters a lot in the same case. So to give an example, Codex is like an agent that's by OpenAI. So Codex can't do search because it's not been trained on search. It has only 3 tools. Cursor can't use even like a lot of these tools. Claude Code has been the only one has these lot of multiple tools. Reason being, as I said in the previous slide, that like the Sonnet and the Opus, the models from Claude Anthropic, they have been trained specifically on these tools, and they are the one who built Claude Code where they provide these tools. So the binding between model and the tools matter a lot. That results into an agent giving a better quality outputs. Another thing that like the new coding agents have in thing is like a YOLO mode sort of thing with full permission. So earlier we had this thing let's say when we are using any of the agent, that used to ask like, yes, allow this thing, allow this particular change, allow to run this bash command, allow to do this particular change, enter into the file. That becomes super annoying. Like for example, if we need to do something in loop, we need to do 10 things at a time and we are experimenting with it. That creates like a big barrier for every time I need to do. Yes, and when it's like not an agentic feature, as a software feature. Once I have given it all the permissions, I don't have to. I can always interrupt in the middle, but I can always like run it and do it without any interruption. And that also contributed a lot in terms of higher adoption, because I don't need to waste a lot of time in terms of like just clicking yes. So this is like the very basics about agent we talked about. Like okay, I've been using for quite a while. I want to share like what I've learned from my experimentation with these agents. So number one thing is, as I said in the beginning, like I'm not vouching for any single agent, but what works for me, what might not work for you. The biggest thing is like everyone has a separate code base, everyone has a separate stack, different things. So they cannot be a generic thing that can be applied on everyone. If you can take one advice from this talk, like just this, focus on experimentation, try out whole bunch of things, and then only you can figure out okay what works and what doesn't. So like agents also, they've been trained on human code, like human written code. So overall, like how we write code, how we do conversations, they tend to imitate that sort of a thing itself. So what works for us works very well for agent in practice. Like for example, if we have a cleaner code base or a clear documentation, that works for us better, like in terms of better writing code. Similar things work for agent. So one of the most important things to adopt any new tool is the user experience. Like if we are not able to use it properly, how much ever technical or how much ever intelligence it has, it will not matter. So like for me especially, like when we work as a programmer, what I need to see, whenever it is doing something, I need to literally see, it should be visible on me, I should be able to interrupt it, and I should be able to provide those feedback. So those three things become like minimum essential things for me to try any of those tools. The choices with the agent, so most of the models they work very well when given simplicity. So like if I specifically talk about programming languages, it works very well with Go, for example, because Go has very less knobs to tweak. Like Go has a very low amount of syntax, and they will, if there are very less to tweak, they will not make a lot of mistakes. Second thing with this, like ecosystem churn. So I'll give an example. For example, when I have to upgrade from let's say Tailwind 3 to Tailwind 4, there's a lot of change. If I just upgrade to Tailwind 4, all the Tailwind 3 code will break and my UI will break, for an example. But like if you're talking about frameworks, programming languages where they have a like full backward compatibility, agents will have flexibility, or the models will have flexibility on that, because they've been trained on the different duration of the time on the agent. Let's say some model that was trained and the knowledge cutoff is 2024, and there have been some new function came in the language in 2025, it will not be able to use it very well unless given the proper documentation. So, but even if it still writes the old code, we should be able to compile it. So for example, if the language or the ecosystem is backward compatible and they have less churns, it works very well in the favor of agents. Another thing is like when in terms of the things that they read. So one of the things that like agents will do is read your code. So if the existing code is very descriptive and like we have long function names and like we have annotated things properly, then it's able to understand things very better than like for example we not having a, if we having a vague name or like X or A or these kind of variable names. So it all depends on like for example how are we giving the context to the agent. So another thing in terms of giving an agent is like the dev environment itself. It's just not our code base. When we run things, when we try and let's say an API call, it need to see the logs to it, and it need a better way to see the logs. Like for example, if we are running let's say agent separately and our service separately, it will not be able to see those logs when we are trying out or testing out the app itself. So we need a way to consolidate all the different types of logs to one single place. So if I show you an example, if you see there are multiple services running and log is in one place. So if the log is in the one place, agents can easily, whenever something breaks, when we are testing things, it can read those logs and it can provide the feedback according to that and make those changes to the things. Another thing is like we all work with the distributed systems. So like multiple services and like agent need to know how these services interact with each other. How do we start and stop? If anyone if we have used those agents, we have seen like for example, we need to restart the server. So if we are let's say running 3 services and if it forgets to restart one service, then we get okay port is already in use, those sort of errors. So that becomes very annoying, but now the entire loop is broken and we can't test it unless like we manually kill that particular process running on the particular code and then come back and start all these things again. So if you provide an environment, let's say like sort of a target where we can just say make start to start all the services and make stop whenever it to let's say restart the server to stop all the services. Now in a deterministic manner it can start and stop those services, and whenever it starts it can literally start consuming those logs as well as it needs. So
how do you give the context to the agent? Do you use MCP servers or if it's a distributed system?
You don't. So first of all we have readmes. So in terms of giving context to agent, you can tell me okay I have these 3 services that how they are interdependent on each other. We don't need to use MCP for that, like if we just document in a small manner. So I'll come to that, like for example now we have this agents file that we provide to the agent to consume some basic context about the project, so we can put all the information over there. And in terms of like how to run those things, there itself we need to tell that okay, if you need to start the service, you just like run the command make start. As I said in the beginning, all the things lies towards tool uses. So for example, these agents are stateless. So one of the main important thing is they don't maintain any state, like the model that running in the OpenAI's data center doesn't know anything about the code. All the secret sauce lies between the running these specific tools. There's a very simplistic tool of reading files, writing files, or finding some certain piece of text in the code. These are the things that are actually executed in our environment or our code base. So let's say whenever we need to start a service, it will use the bash tool. It will run the make on the shell to start the services.
I have one question.
Yeah.
See, when you say don't make it guess your distributed systems, so your services are scaling out and scaling in dynamically.
Okay.
And that maintains its own service registry and all, right? So your agent can be linked to your service registry, and which has a list of all the services running at any point of time, kind of thing, right? So how does that work? Like the dynamic scaling out and scaling on of services, how does that impact the agent?
So there is a difference between deployment and the development part of those things.
Right.
For example, when we are deploying services, we have the entire service discovery platform and all those things.
Correct.
But it works in a different manner. It has not to do with the business logic, for example, but when we are doing the development,
Right.
We need to talk about how the business logic or how the code interacts. So for example, to do a particular thing, or let's say to parse a document, you are running a separate service that your main service talks to that service through gRPC. So that information is you don't generally like state as a deployment. This is a specific information that's there in your code, and you need to tell that okay, this service A is talking to service B on this particular code using gRPC as transport.
That is abstracted.
Exactly. So one of the things that I do, like I'll just talk about the tooling as well. Like when we are running these multiple services, how to do this? There is this tool called Shoreman. Shoreman is like a process manager that can manage all your process and like put logs in a single log file. So you just mention all the services, like how to run each of those services, define those things, and literally you can just like start that Shoreman script, it will read your proc file and do the thing. So yeah. So if you like wondering how does this work, so to do this sort of a thing, you just need to mention individual services and start Shoreman. It can literally run all 4 or 5 of your services simultaneously, and those logs can be a single place in a single log file. So now it's about like we have done development setup. While we are developing, the most important thing is the feedback, like how do we know when things are wrong. So agents would need like a deterministic way of like validating the solution, like whatever solution it has created, the solution works. For that, like we need to write tests. So other than that sort of validation solution, nothing works. Sometimes like a lot of agents do is small scripts. We also, to test something, let's say if we are like too lazy to not write tests, we test using scripts. So with that particular thing, while we are coding in a loop with an agent, we need to tell it how to test it. So either like for example, we have written test, we need to tell about the test. Otherwise like okay, or we need to write script, so we need to tell it okay, this is the folder where you write this throwaway script. This is how you will run. So that like whenever it comes to validation, those the solution that it has created, it will know okay, these are the scripts that will run and to test it, and it can keep on iterating those scripts, and after it is done, it can discard those scripts. So if we have mentioned that very well, it will not clutter our code base. It will not just create scripts anywhere in our code. There is a specific place in our code. It will not go through multiple loops to finding that place if we have mentioned it very well. So overall, just I'm going to re-emphasize on my point again. If we tell what to do as close as in a deterministic manner, if we tell agent what to do and how, where the information is, whatever information it needs, it works very well. If we make it think, if we make it like go around, then it will just like go around to different places. It will take more time, more loops. Now talking about the test itself, like test. Because when we are working with LLMs and non-deterministic systems, then test becomes our gatekeepers. So in the context of tests, we should never white code test or like use agent to write tests specifically, because tests are our guardrails when it comes to production code. But one thing where we can use agents is like writing test scenarios. Like I have some thinking of business logic on the feature I'm building right now. I can make it think and it can generate like those scenarios for me. So those cases it works very well. But in terms of actually writing those tests, it's terrible. If it makes mistake in the test, then we are screwed. Like if it makes mistake in the code, we can again like run our test will fail. So, but if we make mistakes in test, then like it will break in production. So this is like a very simple example of a test, like where I'm just testing like a function where it difference between 2 days, 2 timestamp in terms of number of days. So it can just generate these cases for me, like same day or 1 day apart, or like a boundary of a month where there can be an edge case. So it can always help in finding those edge cases, but like terrible at writing exact business logic of running these tests. So what agents do very well is like when we have these tests, it also need to run those tests. So what happens a lot of times when test starts failing, it will not run those tests. So there was always like every programming language or framework also provides a system to run specific tests, not the entire test suite as well. So when we are running those tests, what happens whenever an agent fails some of those tests, it can start ignoring those tests. It can just say, okay, I run these 3 tests, they might not even be relevant to the feature that you are building. So those sort of things are problematic. So what we can do is similarly how we have consolidated of running our services, we can also consolidate how to run the entire test. If we tell it, okay, don't just do specific tests, whenever you need to run tests, do make test. So make test will run the entire test suite, and it will just run all the tests in specific tests, including when we are building the feature. Obviously when we are running the entire test suite, it will take a lot of time, so we can use a lot of test caching. So like as I said in the beginning of the ecosystem of the programming language selection while working with agentic tools, that for Go provides like a huge big test caching. So for example, whenever the code changes, it will run those specific tests. There are also other test caching methodologies that can be used when we are running the entire test suite for every change. You're talking about, like somebody asked about the MCP server as part of those things. So MCP server is like a double-edged sword. Like it's definitely like a way to provide more tools to the agent. We talked about like providing super simplistic deterministic tools to the agent. But like what is wrong with MCP in this sort of thing? It requires a lot of looping, it requires a lot of conversation. So only one tool that I use is Playwright to talk to browsers. Like talking to browser is not very easy. So and Playwright shines on that particular thing. It can literally go to the browser, find the particular elements in the particular web page, click those things, read console logs and everything, and it can run that into the loop. So the Playwright is the only one. Other places it doesn't work very well. So another example I'll give you is GitHub. So GitHub also provides an MCP. And GitHub MCP is wherever you need to do any action on GitHub, it can use an MCP server. In practice, GitHub also provides like a CLI tool. So when you compare like the same task with the GitHub MCP and the CLI tool, the CLI tools works way better. Like reason being, we discussed in the beginning like how the binding between the model and the tool is very important, because how it has been trained. It has been trained on using bash a lot. Like on the internet there is a lot of shell code. So it knows how to write shell script and run things on shell. But it's not been trained a lot on these MCP protocols. There are some specific new, and when we are working with let's say CLI tools, it can write like a shell script and it can do the job way better than like any MCP server. With the exception of browsers, because like browsers we have the limitation of doing things, and like instead of doing things manually, it can do with this plain MCP. But even in case of browsers, one thing I would say is like whenever there is a block of deterministic thing. So earlier we talked about the test cases, and when I need to test let's say a particular thing in a script or a block, where I need to say okay, on click of this button this X thing happens. If we know always on the click of button X thing happens, we can make like a specific test for it. Instead of like it just going splunking and figuring out on the web page, okay, where is this button, and if I click this button in the deterministic manner, if I tell to run this to test this particular function, you can call this particular test, then it can run that in a deterministic manner, and it doesn't need to just find that particular button and click. So how do we give some of the information? So we talked about like how do we start our servers, how do we like run tests, or how do we give the relationship between services. So recently like most of the agent providers have been agreed on a single uniform format of providing some sort of memory to an agent where we can give some context about the project other than the code base. So there is this thing called file called agents.md. Earlier like everyone had their own codex.md, cloud.md and different things. So agent.md is the one place where we can define how to run a services, how to run a test, like for example practices, like for example we need to use let's say interfaces as any, or if we like for example for a GitHub interaction just use gh command instead of it just figuring out on its own, or like for example to run any SQL query manually to test certain things, just use pSQL and load the environment credential from the envs. So all those things we can just write in the agents.md, and like most of the agents are just configured to read this file first whenever you start a new session. So it can just read the file, get the context from that, like a very simple file where you can just define make start, make dev, test, all the different things in a single file. So now like we talked about the different components of using agent, how do we start like working on it? Let's say if we need to start like working on a big feature, how does it start? Like first of all, we need to create a solution out of it, like we have a problem statement. So here LLMs shine very well. It can work as your colleague or a friend to discuss solution and iterate on the particular solution itself. Like let's say you need to read some documentation, you can tell us okay, go to this particular place, read this particular documentation, or read this particular part of the other service where it is going to talk to. So it can literally do the multiple iteration, do all the planning in terms of how to build the particular feature, think of all the edge cases, think about the testing strategy of the particular thing, and create a plan. What we can do is we can just run all these iterations and save a plan to some plan.md or some particular file. Another interesting thing that is like models are very good at giving feedback. So let's say we are using an agent, when we like iterated over it, created a plan for a big feature, and now we need to get some feedback. So what we can do is we can use like some bigger model where it has more intelligence, it has more compute, and to give some feedback on a particular plan. So I created let's say a plan from Cloud Code. I can use O3 Pro, that's like the most intelligent model from OpenAI to get feedback. So I'm not using O3 Pro for my coding because it's very expensive, but I'm like just getting, because the place where I knew most intelligence in my system architecture or my entire plan. So there I can get some feedback from the more intelligent models and then incorporate those again plan in a iterative manner.
The feedback goes into the agent simplified.
Feedback, so what we can do in this particular case is like for example, whenever we need to talk to let's say some other agent, or then we can use some CLI tools. Again, because models are very good at using CLI tools. So even for using, let's say, another model, I don't need to go to ChatGPT and like paste my entire plan and get some feedback and paste it back. I can literally use some CLI tool that does a similar job, that literally can take my API key from the environment and take the entire file, give it to O3 Pro, get the output and get the output back to the same agentic loop. I'm just still running the same session where I'm planning. I'm not out of that session. I'm in the same session. I just told it, okay, call the CLI tool to get feedback. It will do that on its own and put the feedback in the context window, and it can then again incorporate that feedback and then create a new plan, and I can start the feedback, get the feedback until I'm satisfied with my entire plan. I think that's the place where it takes most of the time, where it takes most of engineering skills. What we do manually right now, we can do with agents as like a peer programmer or a colleague. So once we have plan in place, what do? We need to implement that plan itself. Like if we want to implement that, like there are two things. Now because majority of the architectural part is done, either we do and go ahead and manually implement that plan, or we use again the coding agents to implement that particular plan. So one thing that like people make a lot of mistake in the same session, they can just start doing the code. And what's the problem with that is like if we have like so much iterations, because we have also done a lot of discussions while making that particular plan, all the garbage, all the errors, research, everything is there in the context window of us. And if we start coding as well, it's not going to result into a better code. So because the entire secrets of the output of it, we have already stored in like say plan.md or plan file, it's like a better practice to just start a new session and from the plan itself start and do the coding. I'll talk about context limitation and context window in detail. So another thing that we have nowadays is like background agents, and somebody in the audience asked me for the talk about like PR reviews. So background agent is something that like you can just give it the task, you don't need to monitor it or do anything, it can run on its own and like give you the output sort of a thing. It can run loop on its own. GitHub is the first one. It launched like a background agent, background coding agents as co-pilot, where you assign an issue on GitHub, and it can literally read from that issue and start coding in a particular repo. The problem with that particular flow is we as programmers don't work in one shot sort of a thing. Programming is an iterative process where we need to provide the feedback. If you remember the beginning, the user experience part that I talked about, there we are talking about like I need some environment where I can literally see what it is doing and I can interrupt. I don't want to be in a situation where it runs for an hour and it just gives me some garbage result. I need to throw it away. There should be a flow where I can literally interrupt it and give it the feedback. In case of background agent, that doesn't work. So a lot of the places where we have people giving these tools of background agents where you assign an issue to a GitHub thing, so GitHub issue, that doesn't work very well in practice. So talking about the context window limitations, we all know like all the models they have a context window. Let's say like Claude, most of the Claude model has 200k token limitations. Gemini has like 1 million token limitations. How do we deal with token limitations? Because the entire conversation that we're talking about is in the context window. So LLMs are stateless as we discussed, and they do not retain any information. So every entire conversation we are doing, it just keeps on adding to the context window. So if there is a 200k token context window, that context windows keep on filling as we are doing more conversation or more tasks or tool calling or MCP or whatnot. So like to minimize and then the context window is state resource. So first thing is like how do we minimize things? First thing first, we need to be very specific, because if we are not specific, it will just go on its own, try 100 different things to find a particular context. So be very specific with the task. When we are like we are asking you to do something, it should be very small task and very specific task. So it can just do that task, be done with it, and like if we need to do another task, we start with a new session. So and another thing is like without it doing anything, like we should keep on encourage it to ask clarification questions. It's all give out specifics of the code, okay, because if it doesn't know the specifics or for a feature or the business logic, or if it is not there in documentation or in code, it's our responsibility to give it the context, because it's not going to know any of this context magically, right? Or it's going to screw up. If we don't tell it beforehand, that context or the business logic that our product manager has told us to implement, it's not going to know it on its own. It's going to write like a bad code and it's going to break. So it's our responsibility. We make sure that it asks clarification question and the entire thing what we want to build is there in the context window. So we talked about agents.md file. That's like the basic project structure. So that helps us at giving the high level idea about the project itself. Like the prompt helps in terms of like giving the idea about the specific feature we want to build. So we need to work in the combination of both to get the right value out of the agent. So one interesting thing that like people have found out is like even whatever context window we are getting, even we can't use the entirety of it. So if let's say Claude Sonnet is providing let's say 200k or like recently 1 million context window, we can't completely use entirely. After we use like 40-50% of the context window, it starts giving bad result out of it. Like even the models like Gemini who has like 1 million context window, it doesn't work after a certain threshold. So this has been recent study from DeepMind technical report where they tested 2.5 Pro. They are the most intelligent model that has 1 million token context window. It starts giving diminishing results after 100k. So after 100k tokens itself, it starts giving bad results. So this tells us that whatever we are doing, we should not just do entire thing in a single thread. We should create like sort of a lot of smaller threads, smaller sessions to get better output from these agents. A lot of the programming agents provide a tool to know the context window. So like sometimes when we are in the working, we don't know how much conversation we have had. So they provide tools to analyze what is the context window of our existing session. It can tell us how much system prompt is taking or how much is taken by the tools or the messages or the MCP tools. Another thing that works with context is a lot of these agents provide compact command or some sort of compaction features where if you have filled up the context window, it can do the compaction. But compaction doesn't work very well. It's like a weird thing. It's a non-deterministic. From the entire conversation, if we try to create the gist of it or the summary of it, it's not trained for your code base to generate that summary. Even the most intelligent summarization agent people have built, it's trained for the particular summary or tuned for the particular summary that we want to create. But here the full code base, it's not trained. So if we need to use a compact, it doesn't work. Like it's always useful to start a new session or store some of our context into a file instead of just like keep on doing compaction and starting a new instead of starting a new thread. So this is like another new interesting thing that's been there with coding agents is sub-agents. Sub-agents is like spinning off another agent within an agent sort of a thing. So like let's say if I'm talking about Claude Code will run another Claude Code let's say within its existing session itself. What it basically is, you just give a task similar to you give a task to your main agent, it can like work in the background. So I'll talk about like where it fails and where it works. For example, so what it need to do, right? Like you need to solve a particular problem, get the context and give the result back. Now how it works, let's say if I talk about in context of programming. So programming, you can't just give something very tiny context. If you are building like a large service, if there is a large service, I can give it a small context or can get like a smaller part of it out. If it is a pure thing, let's say if earlier I gave an example of how do you create like a day's difference between two timestamps. This is like very deterministic, a pure function. Even there is an impurity sides of it if the time zone comes into the picture because days difference between two time zones will be a problem. Let's say if I have timestamp of last night 11:55 p.m. and 12:05 a.m. in reality difference is 1 day if I talk about the difference. But if I'm calculating the difference, let's say in UTC, there is 0 day difference because they are both things on the same day. So you understand, right? Like how you can't just give the minimum context. Context is a weird thing, sort of a thing. But where it shines is where we need to do some sort of research. So not in terms of the context, where we need to read some, let's say, scarce documentation or research about the particular topic, or if you are using some sort of new library, or if you are making the upgrade from Tailwind 3 to 4, it can read the Tailwind 4 documentation and tell me bits about okay, what are the things that change between 3 and 4. So instead of a main agent going to that web page, reading the entire page and having all the extra HTML tags of it, it can save some context from it. It can just get it. If sub-agent can do the summarization part from it, we can save the context window. So even though we are not using it for production code, we are using it for our research or one-off task. And that way we can save a lot of context window. So another place is where we do a lot of POCs. So whenever we do, there is this principle of writing code 3 times. It's been popularized in Microsoft. Is like use first of all, just make the feature work, and next time you write the test and iterate on it, and the last one is you refactor on it. So when we are working on like proof of concept of POCs, there we don't need to worry about like lot of production code quality. There, like the most important thing is to how can I make the business logic work very well. So in those cases we can use sub-agents. So that's like one place where we don't need a quality where even if it loses some context or writes bad code, we can live with it. But like here, we can literally spin up a bunch of agents and it can code for us in the background. And the beauty of sub-agent, as we discussed, we can run as many of them as possible because it doesn't rot our context window. It can take the particular task, and do the particular task and say, okay, it is done, and I can run as much as I want. Largest or the longest I have run Claude code on a feature is 3 hours. When I just started a session on a plan and it just worked on it for 3 hours, I went to bed and next morning it gave me something. And my POC was done, like while I was sleeping. So this sort of thing we can do with POCs. Obviously, just be cautious. Do not do this with production code because it's going to leave bugs because it doesn't have proper context. So, like I'm not sure if the screenshot is visible. So this is like an example of on the POC running these agents. So each of these tasks, if it takes let's say 30 minutes or 40 minutes, these are the 40-minute segments that it ran on the particular task while I was sleeping. So we talked about like how to build POCs and different things about it. Like now the question comes on quality. How do we maintain quality on it? Because that's the most important things that matters. So one of the things that we need to understand it very well, these are tools. These are not the replacement for us as the programmer. There have been a lot of news of like AI replacing programmers and everything. I'm not sure if that is there in the near future. There's still a lot of tools. These are the tools that can help us become very, very productive. But we need to think of agency of that code that we push or the agency of that PR that we are submitting for the review. That is with us. We can't just go and say, okay, because this is the screw of an agent, this is not my screw up. If it screws up, it's my screw up, not the agent screw up. So this always has to be there. The agency always lies with the agent. There have been this famous tweet by Dave. He's been author of Complete Code, very famous book in programming, and has been a very experienced programmer from Microsoft. Is like whenever we write code by us or by AI, it doesn't matter. Like responsibility lies on us. The PR that we submit, it's our responsibility. So that's like a very, very important principle that everyone should keep in mind. So now in terms of the when we are actually using the agents. So I talked about feedback part of it. Like if we just run in a single linear thread, then it's very, very prone to make mistakes. Models are very good at providing feedback, providing mistakes. You just tell them it's not that what you wrote or I wrote. It's like written by my colleague. He just give me a feedback, give me a critical feedback on this, and we can just read the feedback and like see if it is an important or not important feedback and iterate on it. The feedback cycle works very very well. Plan execution, as we always talked about, like in terms of quality, do not execute plan with agents. If you on the production code, like plan execution we should do in bits by on our own. For POCs we can run this with sub agents, and do not execute on the plan the same session because it rots the context window. Small feedback cycles matter a lot. As we discussed, LLMs do or the agents do very well when it gives specific tasks. They do not work on a large refactor in one go. they can do small bits or small to-dos. So we should make sure that we only give them small tasks, and with the smaller tasks they do very well, they write like a better code, and it's very easier to test and validate when we are writing the small code. Every small code, every small change as a commit, that individual commit can be reviewed on the test as well as the code we write. It's easier to review, easier to code. I'm repeating this I think multiple times for this new session part of it, because this is a mistake that people make a lot. Even with ChatGPT, we just like use one thread and ask like 100 different questions, and that just keeps on going. That works very well, and like maybe in terms of chat and asking non-technical questions that might work, but when we are writing code where the context itself is huge, when we have like thousands of lines, it doesn't work. It's always more important for a new task, we start a new session and use a new session. With the context window, there is this problem with backtracking. So again, if we are like using the same context window for two different things, or like say in the previous task there was some broken code, then it doesn't know, because it has a mix up of context, and the LLMs are black box. There is no surety, okay, which part of the prompt it will prioritize. There has been a lot of research on it. There is this company called Thinking Machines that have been started, and they've been doing interpretability research in terms of the relationship with the prompt and the deterministic nature of the output. But it's still not deterministic right now, and if we leave some failure or some crap from the previous conversation in the context window, it's going to crap out, or even it can just break the fully working code, and that is even unrelated to existing task. So we always should start like a new session and should not keep any broken code into it, so that it can focus on the particular task that we are doing instead of focusing on the broken code from the unrelated task. Same thing applies to the dev environment. Let's say if my dev environment itself is broken, or the tools that I'm using they have some error, then it's going to focusing on those issues. Let's, for example, if I talk about if I'm doing make start and there is no start command itself, and then it just goes into fixing that. So whatever tools we are providing, whatever instruction we are providing, we should make sure that they work, because they are very deterministic in nature. That's what we can do. That's why we don't need any help in terms of an agent. Maybe if you want that, we can run it as a separate task and fix that first before coming into building a feature. But while we are building a feature or solving a bug, we should make sure that only things that are related to that bug itself are there in the context, or their environment is not broken. Question? So now I'm going to talk about like some secondary use cases, like we talked about agentic loop and how do we code with agents. I've used secondary use cases like PR reviews. So this is like one place where background agent itself shine very well, because it's not about taking a lot of feedback and an iteration. It's about giving feedback. So giving feedback is one shot, and we can like incorporate it and run it in an iteration. So when it comes to PR review, it can take a very long time because depends on length of our PR, and give feedback. CodeRabbit is like a company who's doing very well in terms of PR reviews. They have a background agent that you can literally assign to your PR, and once you make your PR as a review ready, it can run in background and send you an email or a notification once your review is ready. You can incorporate that feedback, push another commit, it can run again another feedback. So this works very well in terms of like one shot or like one shot background agents. CI debugging is like another area that I used it very well where let's say if I talk about my CIs in GitHub Action, it can use CLI tools, so like the gscli command to fetch those logs from CLI, figure out where it is failing. Our build pipelines are also code, so if it is like mentioned in the same repo, it can read the CI pipeline code, how it runs, collate with the logs that are there in the CI pipeline and fix those pipelines. So even with the remote logs on the remote server, we can fetch the logs and fix our issues. There's another interesting part of it, cloud systems debugging. This is where I'm spending most of my time building actually. Is as we see, like models are very good at writing bash, and when we are debugging on a remote system, it's all bash. We are running some command on a terminal. to debugging. So if we know from some let's say Datadog alert or somewhere that okay what happened, literally we can give that problem statement to the agent with the context of our entire system or the deployments, and it can run those commands to do the debugging. Obviously, like for those things, we would need, we don't want to run in a YOLO mode as where we give full permission so that it doesn't run anything. But most of the agents provide like a mode where we can run in interactive mode. Whatever commands they generate, we need to say yes to generate it. So whenever, let's say when it comes to debugging production systems, we should do that. This is like one of the examples is something that I'm building where we can literally give a natural language text to the agent, okay, or like some logs from alert, figure out what went wrong, and it can literally go to, let's say, a Kubernetes cluster and figure out, okay, that this pod is getting into crash loop back, and like now look at the logs of this pod and like see why it is going into crash loop back, and it can run into the loop and solve the problem debugging. This use case of systems debugging works even better than coding, like so much better than the coding, because this is a one-time thing. Code is something that runs thousands or the millions of times on a server, but this is like a one-time thing where you need to do, and it's an interactive thing, and I don't need to remember a lot of commands and like write a lot of bash on my own. This can run very fast, and this helps very well also when I'm debugging, let's say 4 in the morning when I get an on-call alert. And I don't even remember, I don't know if my brain is working very well. It can help me generate that code or the command to do. All I need to do is just validate, okay, whatever is cool, I can run this on the production cluster. So, about the debugging part of those things, in my experience, the Cloud Code or the existing coding agents don't work very well, because as we said, like there is a combination of prompt and the tools. And the prompts are designed for those coding agents to do the programming in the right code, not to do debug. So for those, it's always very helpful to write like a custom agent or use some custom agents who are specifically built for debugging, so that like we can always customize system prompt based on our cluster requirement or our infrastructure, or like provide context in a manner that we want to provide it, instead of like using coding agents for the debugging purposes. And we can also do environment control. So one thing I do is like I create like a sandbox environment where I can give like a read-only credential to the agent, so that like even with the YOLO mode, wherever I don't need to give every permission. Let's say I'm running on GCP and I created a service account with a viewer permission, and I give it full access with the viewer permission. It can run whatever it wants to debug my thing. So this works very fast. I can even run that entire thing in the background and connect it with my entire on-call pipeline. Wherever I get like let's say an alert on Slack on my email, it can literally read from that, run a background agent, do this thing in a read-only manner, figure out, create some nodes, and give me those nodes. So when I get an alert at 2 AM, when I wake up, I have like a lot of analysis in place. And that allows me to just directly jump into the solution instead of me doing a lot of debugging in first hand. So we have talked about like how do we use them, but like we don't know how good something is until we measure it. So how do we measure these coding agents? It's very hard. Nobody has figured this part out. We see benchmarks. So sweep bench or debug bench or the different benchmarks are there. Like none of the benchmarks represent the real value or the real quality of those agents in your system. As I said, because every stack is different, everyone's code base is different. This only gives very high level data on like thinking ability of an agent. So this is like very helpful for, let's say, foundation model builders like OpenAI or Anthropic, or all the other labs, where they just want to make sure that their new model is not worse than the previous model, so that they can just run these benchmarking, see and how it works. But for the programmers where we want to use one agent or the other, these benchmarks are not like the real benchmark. The benchmark is like we just try stuff. As I discussed, a lot of value lies between also the model and the agent the tool integration. How the model has been trained on the particular tool. Some model that might be very intelligent on particular task, that will not be very good at coding. because if it is not trained on a coding specific things. So when we are choosing an agent, we need to make sure that like it has specifically trained on an agent. So initially when we talked about like how the entire thing works, okay, what are the tools it uses or what are the models it uses, it is very important for us to, as programmers who are user of these agents, to understand how they work or like which model has been trained on which tool to use them effectively. It's not about the like me as an AI engineer or a builder of these agents need to know this. Even as a user I need to know this, so that like I know where it's gonna screw up or where it's gonna work as well. So the binding between the model and the tool is very important, and that binding has to be accounted when we are deciding which agent to use. So another thing is like it's also about trust part of those things. Like how do I trust those things? It's the most of the time the information that we get is like from Twitter or some other online information. That might not be the most reliable information. Either we try out ourselves and somebody who we know who has tried out and like what are the agents they are using, we just take from them. Biggest advantage from this is we can discuss with them. It's not about like, it's not a linear thing, right? It's an iterative thing that using these agents of a thing. So there is a lot of elbow greasing or a lot of things to be figured out while using those agents, specifically to your code base, specifically to a use case. Somebody who understands your use case or use case will be able to better communicate or converse with you on usage pattern of these agents. Metrics, like if I talk about like very high level metrics on agentic tool, what they use is like, so it's just like running LLMs calls running in a loop using bunch of tokens. So for each of these agents they use different models, different contexts, different system prompts. So we need to see okay, how many tokens does it use in a turn, how many turns does it take to do a task. Like for example, doing a task might take me like 50 turns on Cloud Code or like 70 turns on Codex. So even though like let's say Codex is cheaper than Cloud Code, I'm spending more token because of the more turns over there. So it's just not like a one-shot thing. We need to think on the multiple different manners. Tool matter a lot. Tool I just showed earlier that like one agent might have 15 tools, one agent might have 3 tools, and tool is everything where it works. Like LLM call is strictly generate text. The text is, unless it turns into a tool call and do something on your computer or your dev environment, it's nothing. So if it is diverse variety of tools, it's gonna do a better job. Another thing is latency. Latency works very well. Like we are impatient people in general, and as humans, and then like we need to figure how if it takes a very long time, that matters a lot also in terms of running a particular call to the LLM. Parallelization matters a lot. Sub-agents I talked about earlier. Sub-agents is a way to parallelize things. In general, main thread of your entire session, programming session with the agent, it will run in a single thread. But for like some particular task like research or reading documentation, I can parallelize. So we need to always see how much it can parallelize for a use case. These are the models. That's like the latest models right now. Like Sonnet, Opus, GPT-5, bunch of open source models are also there that we see. So each model will have like a different parameters. Let's say like most of the flagship models will have trillions of parameters. Q3 Coder has a billion parameter. Kimi, I think Kimi K2.1 is also, I think latest one is trained with a trillion parameters. So all these different, these are the all the like number of parameters that they have, the amount of data that have been trained upon. These are all the things that they matter a lot. And if I talk about like specific in case of open source model, even hosting provider make a lot of difference. So something that I'm using, let's say from Grok with GROQ or Open Router, that also might matter a lot because somebody might be doing prompt caching, somebody might not be doing prompt caching. So because of that, latency will differ or the cost will differ. So there are like so many different factors in terms of choosing a model for the particular agent as well. Pricing, this is like a big thing when it comes to using an agent. We initially when everything launched, it was per token pricing, per million token pricing itself. Now most of the people are moving towards monthly pricing. So monthly pricing works better in case than token pricing, because now we don't need, at least psychologically in our brain, we don't need to, if we have paid $100 in the beginning of the month, I don't need to think about, okay, I can just freely use it for the entire month and use it. Some people think about using local models. Local models are very good at, like, let's say if you're running a RAP or like a smaller task, but for coding we always want to use state-of-the-art latest model, and that model is very hard to run on local. For example, if you talk about if I'm running Qwen3 coder or Kimi K2, it will require like hundreds of thousands of dollars to run it on a local machine. So it's always better to rent than run it on a local machine, specifically for the talking about the models that are built for the programming or the coding purposes. Elephant in the room is security. Like we hear about a lot of these things where it's screwed up in terms of a given task, or like deleted something on the production environment. So it can do a lot of different things. It's risky. We know it can be prompt injectable. We hear a lot of stories about prompt injection attack. But like it's very hard to think about. These systems are non-deterministic, and like if you want to build a guardrail, it's also very hard to build guardrail around a non-deterministic systems. Worst thing what people can do is, like, what we do is we intercept every LLM call, or even at the system call level, where it runs a particular bash command. For example, you can run a file also using a find command. Like find also, even though its purpose not meant to delete a file, with the find itself also we can run a find. It doesn't always need to use RM. If I apply guardrail that okay, do not run RM, it can also delete a file with a find thing. So it becomes very hard to apply guardrails on it, because what will happen, right? Like maybe for the new, let's say for Sonnet, I applied some guardrail, new model comes in tomorrow, that will bypass my new guardrail. If we are talking about agentic system which has search tools, which this has internet access now. If I am using MCP, Playwright MCP now it has access browser also, so it can literally search the internet, even find ways to screw with us. So it can do whatever. Recently, there have been few security supply chain attacks. They have interestingly used specifically coding agent, not LLM in general. So this is from last week, when one Singularity supply chain attack was there on a popular NPM library NX, where they installed a post-install script. What post-install script does for the, whenever after the installation, it searches for like agentic code tools like Claude, Gemini, all those things, and uses those things using prompts to steal tokens, environment credential, SSH keys, all the different things. So literally after the post-install, they try to steal a whole bunch of information from this. Another thing is, like, even while using the agent itself, there have been a production outage just from a copy-paste error itself. When we as a human, when we are doing copy-paste, we just do a command X and command V. But agents don't work, or the models don't work in this manner, right? Sort of a thing. For them, these are two changes. One is deleting that particular piece of code, and then adding that particular piece of code. Now it doesn't have like some sort of clipboard thing where, like, what in our computer, whenever we do command X, it just gets stored in a clipboard. But for agent, it doesn't get stored. When we are deleting 5 lines, those with a negative sign, those 5 lines are stored in the context window. Not that okay, just reverse of these 5 lines, put it to another file. Literally, it will just copy and paste those lines. Not copy and paste, it will just write a new, it will delete 5 lines and add 5 lines instead of cutting and pasting, sort of a thing. So this example, what happens is, like, because it just got confused between the comment that's been there in the code, so it turned the break into a continue. And what it does is, instead of breaking the loop now, it just keeps on going, and it crashes the pod. It fills up the entire memory. It's like a huge memory leak. And for the entire process of deployment, when it is running, it will do memory-based auto scaling, or it will start touching memory. And this is a real example from a company called Sketch.dev, where it happened. This is not a toy example, and where their production systems were down. Latency shot up from 200 millisecond to 1400 millisecond for some of their APIs. and and they had to figure this part out. The solution to this sort of a thing is built like a tool, because as I said, agents are very good at using tools. So if we build a clipboard tool, so instead of deleting and pasting a file, if it can just call the clipboard tool, put those 5 lines into clipboard and use again clipboard to paste it. So this goes to my earlier point in the thing, what works for us as human engineer works better for AI. So if we try to close our environment very close to the agentic environment, very close to our environment, then it performs much better. So with these flaws aside, agent developers put some guardrails to protect us from those things. One of the most common guardrails that people do is pre or post flight checks. So if I take example of, let's say, Cloud Code, they have this small haiku model that runs fast, and every command or every tool we need to run, every bash command we need to run on the environment, it first check for the safety check that okay, can I run this or not. If it is a dangerous command, it gives like and if it is a malicious command, it can check for that. Another place is like reading files from outside the scope. Let's say if I'm running my agent in a particular folder of my particular repository, we want to make sure that it doesn't delete or add code into another repository that's not out of the scope. So when we are doing the pre and post flight calls, we can also make sure that whatever output that model is giving in, it can just check for that, whether I should edit this file or not, or read this file or not. One thing with this is timeout. So we are running tools on bash. It doesn't control the models do not control that system. So let's say if I ran a command and then it takes a very long time, my entire agent is stuck. I can't do anything on this thing now. So one thing people do is apply timeout thing. So even if it fails or does something, I can always retry it. So applying a timeout always helps, so that the session doesn't get stuck, or I need to kill the entire process instead of just like timing it out. If it times out, we can recover from it. I talked about when we are debugging production environment. So agents provide like explicit consent mode. So instead of just taking all the permissions, so this like itself becomes a guardrail. So that like every time it runs something, it asks us, and we can give explicit permission to run this. So one thing also they provide is switching, the mode switching, wherever like within the same session itself, we can switch with the let's say shift tab or something, we can switch these modes, so that let's say I'm doing some particular, when I'm debugging something, let's say staging environment, I can give it permission to run whatever commands. But let's say if I'm running in the production environment, I can literally switch to ask for every prompt, and then it will ask for every prompt to execute the particular command. So this works like as a guardrail. This is like what I do after last week's supply chain attack. This is a very tiny thing, but like alias these things. So I created these two commands for Claude YOLO and Claude Solo. So Claude YOLO is like with full permission, and Solo with zero extra permission sort of a thing. So wherever in the post install script where it tries to search in the path variable with the Claude as a executable, it will not find any Claude as an executable on my shell, because my shell can't run Claude because it doesn't exist in the shell. Only Claude YOLO exists, and Claude I installed outside of my path variable. And just alias to Claude YOLO, and just whenever I have Claude YOLO, it can execute that thing. So this can at least help us. We can give states name also, we can choose whatever we want to give name, Jarvis or whatever, but like that helps at least us in case of some supply chain attack that we talked about, where somebody's literally trying to search run things on your shell without you knowing, and we can protect the server this way with remote execution. So all in all, see, there is no right answer in terms of security, and I am not even sure how much of this matters in terms of really every new technology has risk. In practice, if we are very specific what we are wanted to do, and specific thing we are asking is not to create like a malware ourselves, then it's very safe to run, and it doesn't break. I'm using it extensively for last 6 months, it has not deleted anything on my production clusters. So this works for me. Final advice is like, while we are working these things, we always should keep our engineering hats on. As I said, these are just the tools. We need to always keep our engineering bulb on. We need to always think very, very critically, because we are the programmers, not that agent is a programmer. And whenever we keep on, and agents will have tendency to do that. So the agency crisis that I am talking about is wherever, let's say, they start giving very, very good outputs to us and things don't break. We are very happy and we keep on shifting the agency to the agent. Okay, let it do the thing. Let it not write tests. Whatever it writes, let me push to production in some cases. So this, if this starts happening, one day will come and then it will tend to do something. It will break something in production. So we should always just keep our engineering hats on, engineering bulb on, so that like we don't drop quality. And this teaches us also, like for example, whenever it is doing some things, it finds out a new edge case to our feature, we learn from it. We just use it for that case only, not to do the entire job of us. So again, to summarize my parting advice, focus a lot on experimentation, be very, very specific in the task, on the instruction that we give it to them. Dev environment, provide like a dev environment so that it can do a better job and doesn't lead to context rot. Don't use a lot of MCPs. And start like a new session every time. In terms of pricing, don't commit to an annual pricing. This space is changing very fast. Today Cloud Code is good, tomorrow something else can be a good thing. So monthly pricing is still good, but do not commit to annual pricing. So like for example, if we don't even use it after 2 months, then like we just pay for, even if we get 2 months discount, we pay for 8 extra months. So monthly pricing works very well in terms of commercial. There is a lot of things floating around on Twitter. Now everybody has become expert on this thing. So do not take a lot of advice from any random person on Twitter. At least see what they have contributed to, how much of an experienced programmer they are. Because it always boils down to our actual ability as a programmers, not to use these models. Most of the models are built by the foundation model companies. So these agents are just elbow greasing. I shared the example in the very beginning. It's just like a model that calls tools and read your code. So always rely on the opinion of somebody who knows things. There is a definitely new development happening in this segment every week. Best thing is to try it out yourself. Like obviously we have limited time, but like whatever time you have, try out whatever you can. I think that's the best way to learn and experiment with you and your colleagues. Cool. So this is my email. Like we can discuss questions, but like if you don't have time, we can like I think we are already out of time. You can email me those questions.
Thanks for the session. It's been very grateful to get this kind of an analysis. I mean, people have been taking a lot of photos. It would be better if you can share it in a form of PDF. I think everyone can refer it on their own. Please, because it's a writing slide.
They can reach out to you so you can share this.
Sure. Slides I think I'll share in the Meetup chat, and like specifically question you can like after this, like because one of the thing for my incentive for this entire talk is to, because if you see this is like a very comprehensive 90 slide conversation, and it's like and I have skipped so many things, like for example, how do you run 20 Cloud Code sessions in parallel, or how do you use Git submodules to like work on 2 features at once, or like so many different things to talk about in this very, very diverse area. So my thing is, so you try things out. I am very, very happy to answer your questions also after you try out. You email me or whatever you want to talk about, but this is like something very, very interesting, and there is a learning curve to it. Like whatever I talked about, this my learning from using it for extensively for past 6 months. It's not like just some tool or like ChatGPT where we can ask our questions. This is a lot. Like there is a lot of elbow greasing. There are a lot of knobs to tweak in this area. Even like how to write proper agents.md file is also experimental. So you experiment a lot. I think that is the thing I would say.
You did this as part of what project? Like, what is the product you are developing, or?
So I use it in my everyday work. So not one particular product. So one thing, we are talking about the infrastructure debugging component of it. I run this lab called 73ai.org. So I'm researching on how we can build better debugging agents in context of the cloud infrastructure. So there is a project where I'm using code is open source, and all the learnings that I talked about here are how do you run logs uniformly, or how you run your tests. Everything is documented over there. I can also share that repo link so that you can take reference from it. Cool. Thank you.
Thanks, Priyanshu. That was an insightful session. We'll shortly break out for lunch before